All right, so yesterday we talked about double angle. We also talked about how we have to have it all in the same trig function. Right now we have it in terms of cosine, so we're fine. The issue is one of them is a double angle, one of them is a single. So the first thing we're going to have to do is convert all the double angles into regular single angles. Do you understand what I mean when I say convert double angle in terms of single? Can I rewrite cosine of 2 theta in terms of something where it's just like, oh, cosine of thetas? Okay, so I'll give you about 5 seconds or so. Think about how you could do this. Hint, hint, top of the page. Look at the top of the page, see what we could do. Couple more seconds, and I'm going to have you talk to your partner next to you. All right, turn to the person next to you. How do you think we could do this?
The second one. I don't know. But not in double. Oh, okay. So yeah.
All right, so we see that we need to, I can literally use one of these things at the top. Look, 3 options. I can rewrite cosine double angle in terms of all these. Which one would be the most beneficial? The second one. Why? Because it's only cosine. If I had chosen the first or the third, what the heck? Okay, cool. Now I got inserted, but then I have to convert sine squared into cosine squared. Just choose the second one. It's in terms of cosine, and then we'll be fine. All right, so that's exactly the first thing I'm going to do. Instead of saying cosine of the double angle, I'm going to instead write it as, 2 cosine squared theta minus 1. And then, of course, I have the rest of my function. I'm just going to copy down. Minus cosine theta equals 2. That was just so we see what we're doing. Okay, now that I have this, maybe I can move everything on the left side, set it equal to 0, factor, and solve. Yeah, it's not really different than what we did in section 3. It's just one step more. So in order to get to this step, we had to take cosine double angle, put it in terms of the regular angle. And now it's just like a problem we had in 5.3. Okay, so I'm going to rewrite this and have it in the order of like ax squared plus bx plus c, right? The normal quadratic equation way. So minus cosine theta. I need to subtract 2 on both sides, so I have it equal to 0. So this is minus 3. I'll pause here. If you have questions, if you're lost, right now, at this time, at 9:03 a.m. is the time to ask questions. If you don't understand how we got here, here's your open opportunity. Cool. Okay. So I must factor this. And having it in terms of like cosine of theta is a little intimidating. Like, I don't know, it makes it harder to process because it's not something you've really worked with before. So I'm just going to use our algebra 2 knowledge. If I would rewrite this as 2x squared minus x minus 3, I could factor it a little easier maybe. All right, so I know one of them is going to be a 2x, the other is an x. Those are the only 2 numbers that multiply to 2, 1 and 2. The only 2 numbers that multiply by 3 are 1 and 3. The question is, which goes where? 2x minus 3x plus 1. Okay, and if we FOIL this out, let's see what we get. 2x squared. Let's see, plus 2x minus 3x minus 3. Okay, cool. So this turns into negative x. This is exactly what we wanted. Perfect. All right, just so it's not clogged. Okay, so since I saw that these are the factors, on the left side, I can, instead of saying x, I'm just going to say cosine x. So this is going to be 2 cosine x minus 3 times cosine x plus 1. Those are my factors. Now I must do what? Let me pick someone. Ethan. What do I do now?
U equals 0.
Exactly. Set each factor equal to 0. So 2 cosine x minus 3 equals 0. Did I switch? Oops, sorry. Yeah. Cosine theta. That's okay. You know what? It's one of my bad habits is I'll just switch it into x. Okay. So now I'm looking for the angle where cosine is 3/2. Where on the unit circle is my x value? Remember on the unit circle we have x comma y, the coordinates of our whole unit circle? No, maybe. No. We have our unit circle. Okay. So don't say anything out loud, not yet. Just think in your head. Ready? This is like internal thought time. So where is cosine 3/2? So cosine is literally our x of our xy coordinate. It's our x. So where is my x part of my coordinate 3/2? Let's see. I know this is 1, 0, 0, 1, -1, 0, 0, -1. Where is it 1.5? Where is it 3/2? Nowhere. No solution. Gotcha. Where is cosine of theta equal to 2? No solution. Where is cosine equal to 2? Nowhere. Where is sine equal to 5? Nowhere. All right. So literally, the only numbers that has to be between -1 and 1. This is 1.5. That's not within my bounds. Remember when we were graphing regular sine function, cosine function? Remember when we graph cosine? It goes up, start at 1, down to 0, -1, back up to +1. It just oscillates between those two. Nowhere. It's not going to be equal to 3/2. Nowhere. No solution. Okay, let's do the other side.
So when you're solving it, would it only be one of those 4 quantities?
Oh, no, it could be any of them. But I was showing you the maxes and minimums of x and y. So, of course, if you go right here, x is going to be somewhere between 0 and 1. Y is going to be somewhere between 0 and 1. I was trying to, give you a hint. Hey, look, the maximum it can be is 1. The lowest it can be is -1. Where is it 1.5? Nowhere. Can't be that. All right, cosine of theta equals -1. So where is my x equal to -1? So what I'm verbally doing the inverse. I'm saying, oh, what angle is cosine going to be -1? Pi. Okay? And it just says on the interval. So cool, I'm done. I don't have to add plus 2 pi n because I'm only on the interval. So just to be clear, on this left side, cosine and sine can never be greater than 1. And if I ask you a question like this, it'd be a no solution. It's an extraneous, it's a no solution, doesn't actually work. Okay, so that is the double angle. So that's if we have, instead of taking, one of my angles, I have twice of an angle inside. No, that didn't really make sense. Okay. What if I don't want it? What if I'm given an equation and it has a bunch of powers and I don't want to deal with the powers? How can I reduce the exponents? Power reducing identities. No. So if I have something like sine to the 8th power, right? Sine of theta to the 8th power plus blah, blah, blah. We can't deal with the 8th. How can I rewrite it? How can I reduce the power? It's the power reducing identities. So honestly, if I'm asking you to, the way I'm going to have to ask you is just like how this example says. Rewrite in terms of cosines of multiple angles with no power greater than 1. So if I'm wanting something with no power greater than 1, you're trying to reduce the powers, you'll use the power reducing identities. Okay, I think this is best. It's possible to use double angle identities to derive the power reducing identities. Yeah. Okay, so if I come up to this one right here, how can I get sine squared theta by himself? Subtract 1, and then I have to divide by 2. If you look at your power reducing identities, you'll see sine squared theta is equal to cosine double angle minus 1 all over 2. You see that at the top of your page? No? We see it at the top of page, I don't know, 11, 12, whatever it is. Okay, cool. What if I wanted to get cosine in terms of the double angle? Okay, cool. So it's literally going to be, this one would be cosine of the double angle plus 1 all over 2. So if you're looking at the top of the page where it says power reducing identities, you see cosine squared theta is literally 1 plus cosine double angle all over 2. That's what I mean when I say derive. You can find them, aka rearrange the double angle identities, and you can get the power reducing identities. Wow, so bad. Okay. Similarly, you can do tangent that way as well. Okay, so how do we actually do this? Rewrite sine to the 4th theta in terms of cosines of multiple angles with no power greater than 1. Okay, little review for a sec. How can I rewrite x to the 4th? X squared to the what power? 2nd. Okay, cool. So I could literally rewrite sine to the 4th theta as sine squared theta squared. Yeah? Maybe no? Okay. Cool. So that's the trick, is we're going to rewrite this in terms of sine. So first step is rewrite sine 4th theta in terms of sine squared theta to some power. Trick play, we already did it. It's sine squared theta to the 2nd power. And it also says in terms of cosines of multiple angles. So this just means in terms of cosine double angles, in terms of cosine of double angles. That's all it means. Of multiple angles, it means we're going to be using double angles. Okay, now that we've sufficiently prepped this, let's go ahead and let's do it. Okay, so we said sine to the 4th theta was equal to sine squared theta squared. So looking up above at our power reducing identities, what is sine squared theta equal to? So what I did was instead of saying sine squared theta, I put 1 minus cosine double angle over 2. Okay. Cool. Just want to make sure we're clear. All right, so now I actually have to distribute the square. Okay, so let's rewrite this. I did not want to do that. Okay, so the top, I'm literally going to take 1 minus cosine double angle times 1 minus cosine double angle. This is a trick play. You do not be lulled into an easy sense of 1 minus cosine squared 2 theta. That is wrong. You have to fully FOIL it out. This is what I was talking about yesterday. Don't just distribute the square. It's a binomial. You have to FOIL the top. But the bottom, it will just be over 4. Okay. So go ahead and FOIL out the first, the top line. And this is what you should get. Did I zoom in too much, or is this okay? So think to yourself, are we done? Did we do what the directions wanted us to? Yes, Bradley?
I just have a question for the placement of the square and the cosine. Is it fine if you put the square after the theta, or if you just want to do it?
So like this?
Yeah.
As long as you have the parentheses, that's fine. Because the grouping symbols will help you. So I put the 2 there. So this is cosine squared of 2 theta. Okay, so are we done? Did we actually follow the directions? Are we done rewriting sine to the fourth theta in terms of cosine multiple angles with no power greater than 1? No, we're not. Ugh, this sucks. So this right here, that's a power that's not greater than 1. That's a power that's greater than 1. So is this okay? Highlighting? Okay, cool. So I need to plug in for cosine squared theta. So look at the top of your page. How do we reduce cosine squared theta? So 1 minus 2 cosine. Okay, and I'm going to be plugging in the middle one. 1 plus cosine. And then this, so up here, whatever angle I plug in, I'm doubling. Do you see how it turned the angle I plugged in into 2 times that angle? What angle am I plugging in here? I'm plugging in 2 theta. And so I'm going to be doubling my original angle. Yep. Just going to finish writing this. Okay. So write... oh my god, no. Okay, so right here, this is the angle I'm plugging in, is 2 theta. I'm plugging in 2 theta. Here, what it's doing right here is doubling whatever I plugged in. If I plug in theta, it spits out 2 theta. If I plug in 2 theta, it spits out double, which is 4 theta. So the power reducing identities rewrites it in terms of a double angle. So literally, I'm doubling whatever angle I plugged in. I'm plugging in 2 theta. So I have to double it, and now the angle I'll put here is going to be 4 theta.
So also like 2 theta plus 2 theta.
I mean, when it says 2 times theta, you're just like adding the angle. Yeah. This is a side question. What if I was plugging in like cosine squared of 10 theta? What would the angle be right here? 20 theta, so it's doubling whatever angle I plug in. All right, so going back to our actual problem. Yikes, this is not pretty. Did I scroll too far? Are we okay? Okay, cool, no hands, so we're okay. I need to simplify this. Now the top of my fraction, I have a fraction and a fraction. So what I'd like to do is maybe combine all the things on the top row, but I have to have a common denominator. Right here, I have a denominator, Right here, I have a denominator of 1. Right here, I have a denominator of 1. And right here is my denominator of 2. How can I combine them? What shall I do? Multiply by 2 over 2, multiply by 2 over 2, making a common denominator. Nope, 2 over 2, because 2 over 1 is multiplied by 2. So when I say 2 over 2, think about any number times 1 is itself. So I'm doing a clever form of 1. I'm multiplying by 1, but it's 2 over 2, just so I can make the denominators the same. Okay, so this is the same as 2 over 2 minus 4 cosine double angle over 2 plus, okay, I'll leave it that way. Okay, 1 plus cosine 4 theta all over 2, and then this whole thing is over 4. So the next step, I'm not going to like compute anything. Instead of having everything over 2 on that top line, I'm just going to combine it all in terms of one fraction. Is that too small? Can you see it? That is pretty small. Okay. So I'm just going to rewrite it as 2 minus 4 cosine 2 theta plus 1. Nope. I'm to hold on 5 seconds. You're going to see why I'm doing it this way. Because by writing it as 1, you just undid the work we just did. Okay, all I did was I took this whole thing right here, and instead of having individual, I just wrote it all over 2. Yes, but not done yet. I'm trying to like go step by step to make sure we don't miss anything. But yes, that is the next thing I would like to do. I want to combine like terms on the top. So I have a +1 and I have a 2. So that's going to turn into 3 minus 4 cosine 2 theta plus cosine 4 theta. Now, this is all over 2, and I'm dividing by 4. Instead of dividing by 4, I can multiply by the reciprocal, which is 1/4. Oh, why is this not working? That was a lot. Just right. So I'm dividing by 4. Instead of dividing by 4, I can multiply by 1/4. What? Because if I make this a 1, it no longer has a common denominator, and I wanted to write it all over 2. All over 2 right here. Yep. Okay, dividing by 4, same thing as multiplying by the reciprocal. So it would all be over 8. I wrote answers so people wouldn't ask me that. Yes. No, I'm just kidding. That's not the answer. I just said it. I wrote answer, but it's not the actual answer. It is the answer, yeah. Yes, this is not ideal. But we rewrote sine to the 4th theta in terms of cosines of multiple angles with no power greater than 1. So this at least doesn't have any exponents. All right, give you a couple more seconds. Think of questions. Are we done writing? I don't see, oh, okay, wait. So the next question, we're wanting to solve cosine squared theta minus cosine 2 theta equals 1/2. So that looks very similar to the one we did on the previous page. Do you recognize the difference? So the thing that's squared. So here I have a square instead of a double angle. I have a square. Shoot, let me erase this for a sec. Why is it so laggy? Oh my gosh. All right, so I need to have everything in terms of the same trig function, but it is. Everything's in terms of cosine, so I'm good there. But everything has to have the same angle. I can't have a double angle and a regular angle. So what should I do? Should I have everything in terms of a double angle or have everything in terms of a single angle? Which is easier to convert into? Convert everything into a double angle. Can I rewrite cosine squared theta in terms of double angle? Yeah, who would have thought? It's on the page with power reducing identities. Let's use the power reducing identity. So cosine squared theta is the same thing as the middle one, which is 1 plus cosine 2 theta over 2. All right, so I have 1 plus cosine 2 theta over 2. And then I'm going to rewrite the rest of it, just copying it down. Okay, just to show you, like, what did I plug in? Okay, so cool issue on that left side. One of them has a denominator of 2. The other thing has a denominator of 1. Ideally, I'd like everything to not have fractions. Do we have an idea of what we should do? So I'm gonna multiply both sides by 2. And the reason I can do this is the multiplicative property of equality. Notice I have an equal sign. So as long as I multiply both sides by the number, I can do it. Now, this is different than up here when I was multiplying to make a common denominator. So, just a moment. I'll give you time to write down, but I really want to make sure you're paying attention. When can I just multiply by number, and when do I have to make sure I multiply by 1? If you're making a common denominator, notice everything is on the same side of the equal sign. I cannot just multiply willy-nilly by a random number. I have to multiply by 1 to make a common denominator. But down below, I can multiply both sides by 2 because I have an equal sign. And the multiplicative property of equality, literally, well, you do to one side to do the other. And here I have sides because I have an equal sign. We're good? No. I will in a moment. So I have 2, okay. So I might be showing like too many steps of work, but I also would rather show extra work than not enough. So I have 2 times 1 plus cosine 2 theta over 2. I have 2 times cosine 2 theta, and I have 2 times a half. So the 2 and a half cancel out. These 2 cancel out. So I'm left with 1 plus cosine 2 theta minus 2 cosine 2 theta equals 1. Now I will be moving it onto the left side.
So you multiply both sides if there's a number on the right side, but you multiply by 1 if they're on the left side.
Right, so if you're making common denominators, if you're literally just changing one side of the equation, you have to be multiplying by 1. But if you have an equal sign, as long as you multiply both sides, you can multiply by any number. I just want to make that clear because sometimes, well, this is just a trend I'm seeing in all 5 of my classes, so I want to make sure we like nip it in the bud before you go to calculus. Yes?
For the first one that you did, if you didn't cancel out the 2's and you distributed
You'd have to distribute it?
you don't?
If it didn't cancel out the 2? Okay, so
Because if you do distribute it, then you can't cancel out because it's 0.
I could have wrote it like this. That goes away, and it just turns into 1 plus cosine 2 theta. That's what this whole thing goes into. Alright, so I'm at this line. Did you see how the 1 went away? I just subtracted 1 from both sides because I wanted everything on one side so I could solve, but 1 minus 1 on both sides just goes away. What is cosine 2 theta minus 2 cosine 2 theta? Beautiful. Negative cosine 2 theta. Let's get rid of the negative sign. So if I multiply by negative 1 on both sides, I get cosine of 2 theta equals 0. Now, if I asked you a similar question, if I said, okay, where is cosine of theta equal to 0? For what angle is cosine equal to 0? So I'm asking you a similar question, and then I'll, come back to where we are right now. Yes?
Why can you multiply negative 1 on both sides? You couldn't multiply it differently.
I could multiply by 5 on both sides. I'll just get negative 5 cosine 2 theta equals 0. I was getting rid of the negative in front.
Can you leave it that?
Or you could add cosine 2 theta to both sides. I just don't want a negative in front.
But you told us that we can't, all the numbers are on one side.
So okay, that's not what I said. So up here, notice I'm working on one side of the equation, and I'm making a common denominator. That's when you have to multiply by 1, like a 2 over 2. Okay, maybe I confused you guys worse. I don't know. I can't just multiply this by 2. I had to multiply by 2 over 2 to make a common denominator. Versus down here, I don't have to multiply by 2 over 2. Because I have an equal sign, as long as I do to one side what I do to the other, I'm good.